array pointer, this one. Okay. So this code looks a little bit complicated, but let's look at this one by one. If we compile this one, array pointer, if we run it, okay. So there is an array variable here, which can hold 5 elements, and by doing this, now this pointer pointing to the 0 elements of array. And by doing this, we are creating array pointer, which pointing to this whole array. And by doing this, we are creating array reference, which is array reference to this array. And if we print the size of PTR, okay, so this one. Okay, so if we print this PTR, size of PTR is 8, and size of the value of the pointer is 4. That's because the size of the pointer address in 64-bit machine is 8, because my machine is 64-bit machine, so this is 8. And the size of the int variable is 4 bytes, so it's 4. Because this is pointing to 0 elements of array, so this one is equal to, this one is equals to int, so it's 4 bytes. If we print the PTR2, the size of PTR2 is also 8, because size of the pointer is 8 in 64-bit machine, but the size of this one is different. If we print this one, it's 20, not 4, because this pointer points to this whole array, because there are 5 elements, 5 int type of elements, so 4 times 5 is 20. So this one size of this one is 20. So this is the difference between these two. This one is this one is a pointer array, which is pointing whole array, and this one is a pointer pointing to the 0 elements of the array. So that is the difference. And PTR, the address of PTR is 40, and we can access the pointer PTR to access the array like this one. 0 element is 1, and first element is 2. And we can also access the array elements with the point array like this. There is a difference between here. We dereference first and then use this one. But there is no dereference here, so this is the difference. But the result is same. And we can also access the elements of array by using an array reference, which is this one, like this. 1, 1, and 2. So you hope understand the difference between this pointer and pointer array and pointer reference. And let's get another example of this one. Zero. Let's remove this code. This is tricky code. Okay. If one, so where is and if? This one. Okay, so this is tricky code here. So this program has a global variable a, b, c, which hold 1, 2, 3 respectively, and we are casting a to the array reference like this, and we store it to ARR1. And if you do that, we can access this the value of this global variable just like an array like this. And we don't need to use an auto here. Instead of using auto, we can put this way. So this makes the array reference variable. So we explicitly for casting this a to the array reference, which base type is int and holds the 3 elements. So if we compile this program, save it. And run it. Can you see it? We can iterate on this array reference variable like this to access the global variable a, b, and c. Here 1, 1, 2, 2, 3, 3. So this is tricky. Okay, so this is tricky. It's good to understand the array reference and how array reference and array pointer works, but this is not common to use. Okay, so let's go back to the slides. So let's look at some of the pitfalls when we use pointers. So can you see the problems here? This is very confusing. The type of A is pointer variable. So A is a pointer variable. And B is not a pointer variable. So only A is a pointer variable. So this is very confusing. To make a B pointer variable, you have to put asterisk here. So we can avoid this confusing stuff if we use a type def. So if we use type def, and if we make this one, int ptr is alias to int pointer. So if we define this int ptr, you can declare the 2 pointer variable using this int ptr. So for this one is same as this one. But this one, only A is a pointer variable, B is not a pointer variable. This is not an intuitive way of writing our code. So it's better to use the type def. And another pitfall is that array variable is actually a kind of pointer variable that points to the first index variable, first elements of the array. So A is an array variable. So this is a pointer. So we can assign A to the pointer variable. So this is legal. But the other direction is not possible. You cannot assign pointer variables because you cannot assign pointer variable to array. So what's this called? Array variables. So you cannot assign pointer variable to array variable because array variable is constant versions of pointers. You cannot modify array variable. So it's constant pointers. So this is illegal. Okay, so that's it for these sessions. Let's study about dynamic memory locations in the following sessions.